Hello there, fellow wanderer of the night. Thank you for finding your way here, to this quiet corner of curiosity, where we explore the gentle mysteries that surround us. Tonight, we're going to drift together toward the most profound question our species has ever whispered into the darkness. What lies beyond the edge of everything we know? We'll float through cosmic horizons and dance with infinity, peek behind the curtain of space-time itself, and discover that the universe might be far stranger and more beautiful than we ever dared imagine. We'll visit the very boundaries of knowledge, where science becomes poetry and wonder becomes wisdom. I'm curious, where are you listening from right now? What time is showing on your clock? At this very moment, are you watching stars through a window, or perhaps nestled safely indoors while the world sleeps around you? If you find yourself enjoying these quiet explorations into the heart of existence, please consider leaving a like or subscribing, but only if these midnight musings truly speak to something in your soul. Your support helps us reach other restless minds, seeking comfort in cosmic contemplation. I should warn you though, I find this topic so utterly fascinating that despite my best intentions to help you drift into peaceful sleep, I might accidentally make it too interesting to close your eyes. But let's try together, shall we? So settle in. Let your breathing slow, and prepare to journey to the very edge of everything that is, was, or ever could be. Imagine, if you will, standing in the center of a vast foggy field on a peaceful morning. You can see clearly, for perhaps a mile in every direction, before the mist swallows the landscape, creating a perfect circle of visibility around you. This gentle boundary isn't a wall, it's simply the limit of what your eyes can perceive. The field continues beyond that misty horizon, stretching perhaps for thousands of miles, but you'll never know without walking forward and expanding your circle of sight. Our universe presents us with a remarkably similar situation, though infinitely more grand and mysterious. We live within what astronomers tenderly call the observable universe, a sphere of space and time whose edge is determined not by fog, but by something far more fundamental: the patient, steady speed of light itself. Light, you see, doesn't hurry. It travels at exactly 186,182 miles per second. No faster, no slower, and it has been journeying toward us from the most distant corners of existence for nearly 13.8 billion years. This means that when we look up at the night sky, we're not seeing the universe as it is right now, but as it was when that light began its long pilgrimage to our eyes. The most distant stars we can glimpse are showing us their ancient faces from millions of years ago, like cosmic photographs developing in the darkness. But there's a moment in cosmic history beyond which even light cannot take us. In the universe's infancy, roughly 380,000 years after the Big Bang, space was filled with a hot, dense soup of particles and energy. This primordial fog was so thick that light couldn't travel freely through it, bouncing endlessly between particles like a flashlight beam in a dense cloud. Then, as the universe expanded and cooled, something magical happened. The fog cleared, and light could finally stream freely through space for the first time. This ancient light still surrounds us today, stretched and cooled by billions of years of cosmic expansion into what we call the cosmic microwave background radiation. It's like the universe's baby picture, the oldest light we can ever hope to see, creating a gentle, glowing shell around our entire observable cosmos. Beyond this luminous boundary lies what we might call the Dark Age, not because it was evil or empty, but because light itself could not yet travel freely enough to reach us across the vast expanses of time. This cosmic microwave background forms the ultimate horizon of our vision, much like that misty edge in our imaginary field. It's not a wall or barrier, but simply the furthest back in time that electromagnetic radiation can guide our understanding. The universe almost certainly extends far beyond this observable boundary, but those regions remain forever hidden from our direct perception, veiled behind the gentle curtain of cosmic history itself. What strikes me as particularly beautiful about this limitation is how it connects us to the fundamental nature of information itself. We are, in essence, living inside a sphere of knowledge that expands at the speed of light. gaining about 1 light-year of new observable space every year that passes. Each day brings us slightly more cosmic information, like morning light slowly revealing more of that misty field, although what it reveals are glimpses of an increasingly ancient past. This boundary teaches us something profound about our place in existence. We are observers perched within a bubble of causality, able to perceive and be influenced only by events from which light has had time to reach us. Everything beyond our cosmic horizon exists in a realm that cannot yet touch our lives, cannot send us signals, cannot affect our destiny in any measurable way. We are, in the most literal sense, islanded within our own sphere of possible knowledge, floating in an ocean of cosmic mystery that may be far, far larger than the small portion we can see. Tonight, as you rest your head and close your eyes, remember that you are cradled within this sphere of ancient light, surrounded by the whispered stories of stars and galaxies, whose messages have traveled unimaginable distances just to sparkle briefly before your eyes, connecting you to the very origins of everything we call home. Picture yourself as a child again, standing at the center of your grandmother's enormous garden on a summer evening, just as dusk begins to settle. You have a small flashlight in your hand, and its gentle beam illuminates perhaps 10 feet in every direction, creating a cozy circle of familiar flowers and pathways. But somehow you just know that the garden extends far beyond the reach of your little light, stretching into shadows that hold countless other flowers, hidden pathways, secret corners where rabbits might nest, and where morning glory vines climb fences you've never seen. This is perhaps the gentlest way to understand the profound difference between what we call the observable universe and what might be the actual universe. Our cosmic flashlight, the ability to gather light and other signals from distant space, creates a sphere around us that stretches about 46.5 billion light-years in every direction. Yes, that's larger than 13.8 billion light-years, because space itself has been expanding while that ancient light traveled toward us, stretching the distances like a slowly inflating balloon. But here's where the mystery deepens into something almost mystical. Most cosmologists believe that the actual universe, the true garden of existence, extends far, perhaps infinitely far, beyond our observable boundary. We might be seeing only the tiniest fraction of what truly exists, like that child's flashlight, illuminating just a few flowers in what might be an endless garden stretching beyond every horizon. Think about it this way. If you were to travel to the edge of our observable universe, you wouldn't find a wall or a sign saying universe ends here. Instead, you would find yourself at the center of an entirely new observable sphere, able to see 46.5 billion light-years in every direction from your new vantage point. And if someone lived there, they would see their own collection of galaxies and stars, many of which would be completely invisible to us back on Earth. Their cosmic garden would overlap with ours in some places, but extend into territories we cannot even imagine. This realization is both humbling and magical. It suggests that our entire cosmic neighborhood, everything we've ever seen through our most powerful telescopes, every galaxy we've mapped, every distant quasar and cosmic structure we've discovered, might be like a single grain of sand on an infinite beach. The beach exists, vast and real, but each grain can only perceive its immediate neighbors. Scientists have various ways of thinking about how much larger the actual universe might be compared to our observable portion. Some suggest it could be at least 250 times larger than what we can see. Others propose it might be truly infinite, extending forever in all directions, filled with regions where the laws of physics play out endless variations on the themes we see around us. In such an infinite cosmos, every possible arrangement of matter and energy would occur somewhere, including countless worlds exactly like Earth, and countless versions of you having this very same thought at this very same moment. The beautiful paradox is that we may never know for certain which scenario is true. The actual universe could be finite or unimaginably large, or it could be truly infinite. Both possibilities are equally valid, given our current understanding, and both fill the mind with a kind of gentle vertigo when contemplated during quiet moments like this. What moves me most about this cosmic situation is how it mirrors the human condition in such a poetic way. We each live within our own observable universe of experience. The people we've met, the places we've been, the books we've read, the dreams we've dreamed, yet we sense, don't we, that there are infinite other lives being lived, infinite other stories unfolding, infinite other moments of joy and discovery happening beyond the boundaries of our personal awareness. The actual universe, with all its hidden galaxies and unseen wonders, reminds us that mystery is not just acceptable, but essential to the nature of existence itself. We are surrounded by more beauty, more complexity, more sheer surprising wonder than we could ever catalogue or comprehend. And somehow, knowing this makes our small observable corner of everything feel not diminished, but infinitely precious, like finding ourselves in possession of the most beautiful page from an endless library of cosmic stories. As you settle into sleep tonight, let yourself float on this gentle truth. You exist within an ocean of existence so vast that even our boldest dreams barely touch its shores. There's something wonderfully patient about the way the universe reveals itself to us, like a shy friend who shares secrets, only gradually, one gentle confidence at a time. Every single day, in fact, every moment you've been listening to these words, our sphere of observable reality has been growing larger, welcoming new photons that have completed their ancient journeys from distant stars and galaxies, carrying news from corners of existence we've never seen before. Imagine the universe as an enormous library, and we're sitting in a reading room at its center. Every second, a librarian delivers new books to our table, books written by starlight millions or billions of years ago, finally arriving for us to read. We never run out of new material because the library is so vast, and the books have been traveling toward us for so long that there's always another story, another chapter, another whispered piece of cosmic news, making its way across the darkness to reach our eager eyes. This is actually happening right now. As you rest, while you listen to my voice, light that left distant galaxies, when the universe was much younger, is arriving at Earth for the very first time. Telescopes around the world are catching these ancient messengers, and tomorrow we'll know slightly more about the cosmos than we did today. Our sphere of awareness expands at exactly the speed of light, about 186,282 miles every single second, gaining roughly 1 light-year of new observable space each year that passes. But here's what makes this process so beautifully paradoxical. The new information we receive is actually very old news. When we expand our vision deeper into space, we're simultaneously looking further back in time. It's as if that cosmic librarian is bringing us books in reverse chronological order, with the newest arrivals containing the oldest stories. Each day, we see the universe as it was in increasingly ancient epochs, watching the cosmic story unfold backward as we peer deeper into the darkness. Think of it like archaeological layers in reverse. Instead of digging down through soil to find older artifacts, we're looking out through space to find younger galaxies. The most distant galaxies we can see are showing us what they looked like when the universe was just a cosmic infant, perhaps 500 million years old or less. These ancient nurseries of stars appear to us as they were when the first generation of galaxies was just learning how to gather matter and light their first stellar fires. This means that our understanding of the cosmos is always deepening, always becoming more complete, but also always reaching further into the mysterious past. We're like historians whose archive keeps growing, but only by adding older and older documents. Each new telescope, each advance in our ability to collect and analyze cosmic light, pushes our vision further back toward the very beginning of everything. The James Webb Space Telescope, for instance, has recently begun showing us galaxies from when the universe was only 400 million years old, babies by cosmic standards, yet appearing as ancient artifacts to our modern eyes. These distant island universes look different from the mature galaxies in our cosmic neighborhood, more chaotic and energetic, still in the process of becoming themselves. It's like comparing baby photographs of your grandparents to their portraits as adults, seeing the same essential nature, but in a wilder, more unsettled form. What fills me with quiet wonder is how this expanding sphere of knowledge mirrors the growth of wisdom in a human life. We don't suddenly understand everything at once. Instead, understanding comes gradually, patiently, often revealing connections and patterns we couldn't have perceived before. The universe seems to operate on this same principle, offering us its secrets at a pace we can absorb, ensuring that there will always be more to discover, more to wonder about, more questions to ask in the gentle darkness of a night like this. Every time you look up at the stars, remember that you're seeing further than any human who lived before you. The light reaching your eyes tonight includes messages from galaxies that were invisible to every previous generation. You are, quite literally, living at the expanding edge of human knowledge, participating in the slow, cosmic conversation between matter and consciousness that has been unfolding for nearly 14 billion years. In this sense, we are all cosmic explorers, all riding the growing wave of light and information that carries us deeper into the mystery of what it means to exist in such an impossibly vast and patient universe. Close your eyes for a moment and imagine you're a tiny ant walking across what seems to be perfectly flat ground. The surface beneath your feet stretches endlessly in every direction, and as far as your little ant senses can tell, you're traversing an infinite plane. But now imagine that you could somehow float up and look down from a great height. You might discover that what felt flat was actually the gently curved surface of an enormous sphere, so large that its curvature was imperceptible from your tiny perspective on its surface. If you won the surface you're in. This gentle thought experiment touches on one of the most profound questions we can ask about our cosmic home. What is the actual shape of the universe itself? It's a question that sounds almost impossibly abstract, yet it holds the key to understanding not just where we are, but where we're all going together on this grand cosmic journey. You see, the universe, all of space and time, might curve and bend in ways that are invisible to our everyday experience, just like that ant on the enormous sphere. Einstein's beautiful theories showed us that matter and energy actually warp the fabric of space-time itself, creating curves and valleys in the cosmic landscape. But the question that keeps astronomers awake at night is this: what is the overall, large-scale geometry of everything that exists? What is the overall, large-scale geometry of everything that exists? There are three possibilities, each more fascinating than the last. Whole, the universe might be flat, like an infinite sheet of paper that extends forever in all directions. In such a cosmos, if you could somehow draw a triangle using the paths of light beams, the angles would add up to exactly 180 degrees, just as they do in the geometry you learned in school. Parallel lines would remain parallel forever, never meeting, never diverging, maintaining their patient distance through all of space and time. Or perhaps we live in a positively curved universe, shaped like the surface of an enormous sphere. In this cosmic geometry, parallel lines would eventually meet, like lines of longitude that start out parallel at the equator, but come together at the poles. If you could travel far enough in what seems like a straight line, you might find yourself returning home from the opposite direction, having circumnavigated the entire cosmos like a cosmic Magellan. The universe would be finite, but without boundaries, like the surface of Earth, where you can travel forever without ever reaching an edge. If you can travel far enough in what seems like a straight line, you might find yourself returning the cell. The third possibility is perhaps the strangest of all, a negatively curved universe, shaped like an infinite saddle. In this cosmic geometry, space curves away from itself, creating more room than you might expect.
Rias Kruvnureg for play in these folk corvias play smooth.
Triangles drawn with light beams would have angles that add up to less than 180 degrees, and parallel lines would diverge, growing ever further apart as they stretch across the cosmos. Such a universe would be infinite and expand forever, growing not just larger but actually more spacious, creating ever more room for new possibilities. Each of these geometries leads to a different cosmic fate. A flat universe would expand forever, but gradually slow down, eventually reaching a state of maximum entropy, where all the stars have died and all the black holes have evaporated, leaving only a cold, empty darkness filled with elementary particles drifting apart at unimaginable distances. A positively curved universe might eventually stop expanding and collapse back on itself in what cosmologists poetically call the Big Crunch, with all matter and energy rushing back together in a mirror image of the Big Bang. A negatively curved universe would expand forever with ever-increasing speed, growing more spacious and more empty as time stretches toward infinity. The remarkable thing is that these aren't just abstract mathematical possibilities. They're real, physical descriptions of the actual cosmic space you're floating through right now. The geometry of the universe determines not just its ultimate fate, but the very nature of distance, direction, and possibility itself. It shapes how galaxies cluster, how light travels, how time passes, even how space itself behaves on the largest scales. And here's what makes it even more beautiful. We're actually living through the process of discovering which description is true. Through careful measurements of distant supernovae, the cosmic microwave background, and the large-scale structure of galaxies, astronomers are slowly determining the actual shape of everything that exists. It's like being cosmic surveyors, using the entire observable universe as our measuring stick to discover what kind of space we call home. Picture yourself standing on a beach at sunset, watching waves roll endlessly toward the shore. Now imagine trying to walk to the end of the ocean. You could walk along the coastline forever, tracing every inlet and bay, but you would never find a place where the water simply stops and gives way to something else entirely. The ocean is finite. It contains a specific, measurable amount of water, yet it has no edge, no boundary, where you could stand and point to where the ocean ends and the not-ocean begins. This is one of the most mind-bending possibilities for our universe. It might be finite in volume, containing a specific amount of matter and energy, yet have no boundaries whatsoever. Just as Earth's surface is finite, but boundaryless, our three-dimensional space might curve back on itself in a way that allows you to travel forever without ever reaching an edge. Imagine being a cosmic voyager with an infinitely fast spaceship, setting off in what appears to be a perfectly straight line. You pass our solar system, then our galaxy, then the local group of galaxies, then clusters and superclusters of galaxies, traveling for billions upon billions of years. In a finite, curved universe, you might eventually see a familiar sight on the horizon, the back of your own head, the light from your departure, having traveled around the entire cosmos to greet you from the opposite direction. You would have circumnavigated the universe itself, like a cosmic Magellan, proving that space, like Earth, is round. This scenario fills me with a particular kind of wonder, because it means that somewhere out there in the darkness, there might be light that left Earth millions of years ago, carrying images of dinosaurs and ancient forests, still traveling around the cosmic sphere, potentially visible to alien astronomers in distant galaxies, as a window into our planet's deep past. Every photon ever emitted might still be out there somewhere, carrying its message through the curved pathways of space-time. But there's another possibility that's equally astounding. The universe might be truly infinite, extending forever in all directions, containing an unlimited amount of matter and energy arranged in patterns that never repeat exactly, but explore every possible combination across the endless expanse of space. In such a cosmos, everything that can happen does happen somewhere. This infinite universe would contain not just more galaxies like our Milky Way, but every possible variation of galaxy that the laws of physics allow. There would be regions where the familiar constellations appear in slightly different arrangements, worlds where the dinosaurs never went extinct, countless versions of Earth, where history unfolded along different paths. In fact, in a truly infinite universe, there would be infinitely many exact copies of you, lying in bed at this very moment, listening to these very words, along with infinitely many versions where you made slightly different choices, or where the physical constants are arranged just differently enough to create new possibilities for matter and life. The beautiful paradox is that both scenarios, finite and infinite, are equally valid possibilities given our current understanding. The universe could be a cosmic sphere, elegant and complete, containing everything that exists within its curved boundaries. Or it could be an endless sea of possibilities, stretching forever beyond every horizon, ensuring that no matter how far we travel or how much we discover, there will always be more mystery, more beauty, more surprising arrangements of matter and energy waiting to be found. What moves me most about these possibilities is how they both lead to the same profound realization. We are part of something unimaginably larger than ourselves, whether that something is a perfect finite whole or an endless exploration of what's possible. In either case, our existence here, our capacity to wonder about these questions, our ability to love and dream and contemplate the nature of reality itself, represents something precious and perhaps rare in the cosmic scheme. Whether the universe is finite or infinite, curved or flat, bounded or boundaryless, we find ourselves in the extraordinary position of being conscious observers, able to contemplate the very nature of the space that contains us. We are, in a sense, the universe becoming aware of its own geometry, matter arranged in such a way that it can wonder about the shape of everything that exists. Tonight, as you drift towards sleep, let yourself float on this gentle mystery. You are either part of a perfect finite whole or a single note in an infinite symphony of possibility. Imagine trying to determine the shape of Earth while standing in your backyard with nothing but a ruler and a compass. It seems impossible, doesn't it? The curvature is so gentle, the scale so vast, that your small section of ground appears perfectly flat. Yet over centuries, clever humans found ways to measure our planet's true shape using shadows, stars, and sailing ships, gradually piecing together the beautiful truth that we live on a sphere floating in space. Today, we face an infinitely more challenging version of this same puzzle, armed with telescopes instead of rulers, and using distant galaxies instead of shadows. Astronomers are attempting something that would have seemed like pure fantasy to those early Earth measurers, determining the actual geometric shape of the entire universe itself. The cosmic rulers we use are quite remarkable. When massive stars die in spectacular explosions called type Pro supernovae, they briefly shine with almost identical brightness, making them perfect standard candles for measuring cosmic distances. It's like having lighthouses of known intensity scattered throughout the universe, allowing us to calculate how far away they are by measuring how bright they appear to our telescopes. When we compare these distances to how fast the galaxies containing these supernovae are moving away from us, we can trace the expansion history of space itself. But here's where it becomes beautifully subtle. In a curved universe, light doesn't travel in the straight lines we might expect. In a positively curved cosmos, light rays that start out parallel gradually converge, making distant objects appear larger than they would in flat space. In a negatively curved universe, parallel light rays diverge, making distant objects appear smaller. By carefully measuring the apparent sizes and brightnesses of these cosmic lighthouses, we can detect even the gentlest curvature in the fabric of space-time itself. Another cosmic measuring tool comes from the universe's baby picture, that cosmic microwave background radiation we explored earlier. This ancient light carries within its subtle variations a record of tiny density fluctuations from when the universe was only 380,000 years old. These fluctuations had a characteristic size, determined by how far sound waves could travel through the hot, dense plasma before the universe cooled enough for light to travel freely. Think of it like this. If you could somehow listen to the universe when it was young, you would hear a cosmic chord, a fundamental tone determined by the physics of that ancient era. The size of the hot and cold spots in the cosmic microwave background tells us about this primordial sound, and by measuring these spots carefully, we can determine whether space is flat, curved, or saddle-shaped with remarkable precision. The results of these cosmic measurements have been quite startling. Multiple independent techniques all point to the same surprising conclusion. Our universe appears to be remarkably, almost perfectly flat. The angles of cosmic triangles add up to 180 degrees within the precision of our instruments. Parallel lines remain parallel across billions of light years. The geometry of space appears to follow the familiar rules you learned in school, just on an unimaginably grander scale. This flatness is actually quite mysterious and beautiful. In the early universe, even tiny deviations from perfect flatness would have grown rapidly, as space expanded. A universe that started out even slightly curved would have become dramatically curved by now, or would have collapsed long ago. The fact that we observe such precise flatness suggests that something in the universe's early history, perhaps that rapid inflation we'll explore later, stretched space so thoroughly that any initial curvature was flattened out, like inflating a balloon, until its surface appears flat to an ant walking on it. Yet this flatness leaves us with a profound puzzle. A perfectly flat universe extends infinitely in all directions, containing an infinite amount of matter and energy. This means that our observable sphere, vast as it is, represents exactly 0% of the total universe. We are not just small, we are infinitely small, a single point of awareness floating in an endless sea of galaxies and possibilities. But perhaps that's the most beautiful measurement of all, not the precise angles or the careful distances, but the humbling realization that we exist in a cosmos so grand that our most sophisticated instruments can barely begin to map its true extent. Every measurement we make, every cosmic ruler we deploy, only serves to emphasize the magnificent scale of the mystery we're privileged to inhabit and contemplate. Imagine holding a balloon in your hands, not an ordinary balloon, but one made of space and time itself. Now picture inflating this balloon, but not gradually like you might at a birthday party. Instead, imagine it expanding so rapidly that in less time than it takes light to cross the width of a proton. This isn't science fiction or poetic metaphor. This is quite possibly what happened to our entire universe during the first fraction of a second after the Big Bang. This moment of cosmic inflation represents one of the most remarkable ideas in all of science. A period when the universe underwent expansion so rapid that it makes the continuing expansion we observe today seem like the leisurely drift of clouds across a summer sky. We're talking about growth rates that dwarf anything in human experience, faster than the speed of light, faster than any rocket or explosion, faster than the very particles of matter could possibly travel through space. But here's what makes this even more mysterious and beautiful. The universe wasn't violating the cosmic speed limit during inflation. Nothing was actually moving through space faster than light. Instead, space itself was expanding, stretching like taffy, carrying matter and energy along for the ride. It's the difference between running across a moving walkway and having the walkway itself stretch beneath your feet. Einstein's speed limit applies to objects moving through space, but space itself can expand as rapidly as the laws of physics allow. Picture it this way. Imagine you're an ant walking across a sheet of rubber, and suddenly the rubber begins stretching in all directions. From your perspective as the ant, you're not moving any faster than before, but distances that were once manageable are suddenly growing enormous. 2 points on the rubber that were once close enough to touch are rapidly separating, not because they're moving through the rubber, but because the rubber itself is expanding between them. This cosmic stretching happened during what physicists call the inflationary epoch, lasting perhaps from 10 circumflex 36 seconds to 10 circumflex 32 seconds after the Big Bang. Time intervals so brief that the entire age of the universe since then seems like an eternity in comparison. During this inconceivably short period, regions of space that were once in close contact, able to exchange energy and information, were suddenly separated by distances so vast that light hasn't had time to travel between them even now, nearly 14 billion years later. The energy driving this rapid expansion came from the quantum fields that permeate all of space, invisible oceans of possibility that normally fluctuate at the smallest scales, but occasionally, under just the right conditions, can release enormous amounts of energy. Think of it like a ball balanced on top of a hill, containing tremendous potential energy. When the ball finally rolls down the hill, all that stored energy gets released. During inflation, quantum fields throughout space simultaneously rolled down their hills, releasing energy that drove the exponential expansion of space itself. What fills me with wonder about this process is how it connects the smallest scales of reality to the largest. The quantum fluctuations that triggered inflation were smaller than atoms, yet their effects shaped the structure of the entire observable universe. Tiny ripples in the quantum foam became the seeds for galaxies, stars, planets, and ultimately for conscious beings like us, who could one day contemplate this extraordinary origin story. The end of inflation was as dramatic as its beginning. When the quantum fields finally settled into their lowest energy states, all that energy had to go somewhere. It was converted into heat, light, and matter. The hot, dense plasma that we call the beginning of the Big Bang, as traditionally understood. In a sense, inflation was the Big Bang, the moment when our cosmic story truly began, while what we usually call the Big Bang was more like the universe's first breath after its moment of rapid stretching. This means that the cosmic microwave background radiation we explored earlier, that ancient light from 380,000 years after the Big Bang, carries within it the faint traces of inflation itself. The tiny variations in temperature across the sky are actually quantum fluctuations from the inflationary epoch, stretched across the entire observable universe and frozen into the cosmic architecture we see today. Tonight, as you rest in the quiet darkness, remember that every atom in your body, every photon of starlight, every grain of cosmic dust was once part of that primordial stretching carried along on the greatest expansion in cosmic history. Sometimes the most beautiful solutions in science are like finding the missing piece of a jigsaw puzzle that suddenly makes sense of dozens of scattered fragments you'd been trying to fit together for years. The theory of cosmic inflation is one of those rare, elegant insights that solved several cosmic mysteries all at once, like a single key that opens multiple doors to understanding. Before inflation was proposed, astronomers faced what seemed like an impossible coincidence. When they looked at the cosmic microwave background radiation, the ancient light from the universe's infancy, they discovered something that shouldn't have been possible. The temperature of this primordial glow is remarkably uniform across the entire sky, varying by only tiny fractions of a degree, no matter which direction we look. This might not sound surprising until you realize what it means. Imagine two regions of the sky on opposite sides of Earth. The ancient light we see from these regions comes from parts of the early universe that were separated by distances so vast that light couldn't have traveled between them in the time available since the Big Bang. They were, in the language of physics, causally disconnected, unable to communicate or share energy in any way. Yet somehow, impossibly, they had almost exactly the same temperature. It's like finding that two people who have never met, never communicated, and live on opposite sides of an isolated island are humming the exact same tune. How could regions of space that had never been in contact with each other reach such precise thermal equilibrium? This became known as the horizon problem, and it puzzled cosmologists for decades. Inflation provides an elegant solution that's almost poetic in its simplicity. Those distant regions that appear to have never been in contact actually were in intimate communication before inflation began. They started out as neighboring regions in a universe smaller than an atom, close enough to share energy and reach the same temperature. Then, during the brief inflationary epoch, they were stretched apart so rapidly that they're now separated by billions of light years, like two friends who started out holding hands but were carried to opposite sides of an expanding cosmic ocean. But inflation solved another puzzle that was even more mysterious. When astronomers measure the geometry of space on the largest scales, they find that the universe is remarkably flat, so close to perfect flatness that it requires explanation. In the early universe, even tiny deviations from flatness would have grown rapidly as space expanded. A universe that started out even slightly curved should have become dramatically curved by now, either collapsing quickly back on itself or expanding so rapidly that matter could never clump together to form stars and galaxies. The fact that we observe such precise flatness is like balancing a pencil perfectly on its point, theoretically possible, but so unlikely that you'd suspect some mechanism is keeping it balanced. Inflation provides that mechanism. During the rapid expansion, any initial curvature in space was stretched flat, like inflating a balloon until its surface appears perfectly flat to an ant walking on it. What might have started as a highly curved, chaotic geometry was smoothed into the flat, uniform space we observe today. Perhaps most remarkably, inflation also explains where the seeds of cosmic structure came from. the galaxies, stars, and planets we see today all grew from tiny quantum fluctuations that existed during the inflationary epoch. These fluctuations, random variations in energy and matter at the smallest possible scales, were stretched by inflation from subatomic sizes to cosmic proportions, becoming the density variations that would eventually grow into all the large-scale structure we observe in the universe. It's profoundly beautiful to think that the quantum uncertainty principle, which governs the behavior of individual atoms and particles, also shaped the distribution of galaxies across billions of light-years. The same physics that makes it impossible to know both the position and momentum of an electron also determined where the Milky Way would eventually form. We are, quite literally, children of quantum mechanics writ large across the cosmos. What moves me most about inflation is how it transforms what seemed like impossible coincidences into natural consequences of a single, elegant process. Curiosores. What scene of you wonders, you four of you wonders, scene of you wonders. The uniformity of the cosmic microwave background, the flatness of space, the existence of galaxies and stars, all of these apparent miracles become inevitable outcomes of that brief moment when space itself learned how to stretch. In solving these cosmic puzzles, inflation reveals something profound about the nature of reality. The universe is far stranger, far more dynamic, and far more interconnected than our everyday experience could ever suggest. If cosmic inflation really happened, and most physicists now believe it did, then it leads us to one of the most mind-expanding possibilities in all of science. Our entire observable universe, with its billions of galaxies and countless stars, might be nothing more than a tiny bubble in an unimaginably vast cosmic ocean. One small region where inflation happened to stop while continuing endlessly everywhere else. Picture, if you will, a pot of boiling water on a cosmic stove. Each bubble that forms and rises to the surface represents a region where inflation ended, where the rapid expansion slowed down and allowed matter and energy to condense into the familiar forms we see around us. Atoms, stars, planets, galaxies. But the boiling itself never stops. In the spaces between bubbles, inflation continues eternally, creating an endless foam of pocket universes, each one potentially as vast and complex as our own observable cosmos. This process, which physicists poetically call eternal inflation, suggests that our Big Bang wasn't the beginning of everything, but simply the moment when inflation ended in our particular cosmic neighborhood. Elsewhere, in regions we could never reach or observe, inflation continues to stretch space and create new bubble universes at an exponential rate. Every second, countless new universes are born, each one destined to evolve its own stars, galaxies, and perhaps even its own forms of life and consciousness. What makes this scenario even more extraordinary is that each bubble universe might have slightly different physical properties. The fundamental constants of nature, the strength of gravity, the mass of electrons, the speed of light, might vary from bubble to bubble, like different recipes being cooked in different cosmic kitchens. What makes this scenario even more extraordinary is that each bubble universe might have slightly different physical properties. The fundamental constants of nature, the strength of gravity, the mass of electrons, the speed of light, might vary from bubble to bubble, like different recipes being cooked in different cosmic kitchens. Some universes might have gravity so strong that stars burn out quickly and collapse into black holes before planets can form. Others might have such weak nuclear forces that atoms themselves cannot hold together, creating realms of pure energy and elementary particles. But scattered throughout this multiverse, there would also be bubbles with just the right conditions for complexity to emerge. Universes where matter can form stable atoms, where stars can shine for billions of years, where planets can harbor oceans and atmospheres, where evolution can sculpt life from simple chemicals, and where conscious beings can eventually emerge to wonder about their place in the cosmic scheme. This perspective transforms our understanding of what lies beyond the edge of our observable universe. Instead of simply more galaxies arranged in patterns similar to what we see nearby, there might be a boundary unimaginably far away, where our bubble meets the eternal inflation that surrounds it. At this cosmic horizon, space itself might still be stretching at exponential rates, creating new volume, new possibilities, new worlds faster than we could ever catalogue them. But here's the beautiful paradox. Even if eternal inflation is real, even if we exist in just one bubble among infinitely many, we could never directly observe or visit these other universes. They are separated from us by regions of space that are expanding faster than light, creating an impassable barrier that isolates each bubble universe within its own sphere of possibility. We are, in the most literal sense, alone with our own cosmic inheritance, able to contemplate but never confirm the existence of our neighboring realities. This isolation isn't lonely though, it's liberating. It means that our universe, our galaxy, our solar system, our planet, and our lives represent something precious and irreplaceable in the cosmic order, even if there are infinite other versions of reality, even if every possible arrangement of matter and energy exists somewhere in the eternal multiverse. There is still something unique and valuable about this particular arrangement, this specific story that includes your existence here and now. The implications of inflation also suggest that the question what lies beyond the edge of the universe might be unanswerable, not because we lack the technology or intelligence to find out, but because the answer exists in a realm that is fundamentally disconnected from our own. The edge of our universe might not be a place, but a process. The ongoing creation of space itself, the eternal dance of expansion that gave birth to our cosmic home and continues to birth countless others in dimensions we can barely imagine. As you settle into sleep tonight, let yourself marvel at this possibility. You might be floating in a single bubble of possibility within an infinite ocean of creation, precious precisely because it is bounded, beautiful precisely because it is temporary, meaningful precisely because it is the only universe you will ever know. Imagine opening a book of infinite pages, where each page contains a complete story of reality, and you discover that you've been reading just one page your entire life. This gentle metaphor begins to capture the profound possibility that our universe, everything we can see, touch, measure, or even imagine, might be just one chapter in an endless library of existence that physicists call the multiverse. But here's what makes this idea so beautifully complex. There isn't just one type of multiverse that scientists contemplate. Like nested Russian dolls, there are multiple levels of parallel realities, each more expansive and mind-bending than the last. The simplest, most conservative version is what cosmologists call the level 1 multiverse, and it emerges naturally from what we already know about our seemingly infinite cosmos. If space truly extends forever in all directions, as our measurements suggest, then given enough distance, the laws of probability guarantee that every possible arrangement of matter and energy must occur somewhere. Think of it this way. If you shuffle a deck of cards an infinite number of times, every possible arrangement will eventually appear, including any specific sequence you could imagine. In an infinite universe, matter and energy are like cosmic playing cards, shuffled and reshuffled across vast distances until every possible combination emerges. This means that somewhere out there, perhaps 10 circumflex, 28 meters away, a distance so large that writing it out would require more digits than there are atoms in our observable universe, there exists another region of space, exactly like our local cosmic neighborhood. Every atom would be in precisely the same place. Every star would shine with identical brightness, and there would be another version of you, lying in bed at this very moment, listening to these same words, with the same thoughts drifting through your mind. But the level 1 multiverse is just the beginning. The level 2 multiverse emerges from that eternal inflation we explored earlier, where our Big Bang was just one bubble in an endless foam of creation. Each bubble universe might have different physical laws, different fundamental constants, different rules governing how matter and energy interact. Some bubbles might have 10 dimensions of space instead of 3. Others might have gravity billions of times stronger or weaker than ours, creating realities so alien that we couldn't survive there for even a fraction of a second. Yet scattered among these strange bubble universes would be others with conditions similar to our own. cosmic islands, where carbon can form complex molecules, where stars can shine steadily for billions of years, where planets can maintain liquid water, where life can emerge and eventually develop consciousness, sophisticated enough to contemplate the nature of existence itself. What strikes me as particularly poetic about this layered vision of reality is how each level of multiverse emerges naturally from well-established physics, yet leads to implications that stretch our understanding to its absolute limits. The Level 1 multiverse requires only that space be infinite, which our best measurements suggest is likely true. The Level 2 multiverse follows from inflation theory, which solves several important cosmic puzzles and has strong observational support. These aren't wild speculations, but careful extrapolations from some of our most successful scientific theories. Yet they lead to the profound realization that what we call the universe, everything we've ever seen or could ever hope to see, might represent an infinitesimally small fraction of what actually exists. We might be like fish in a single pond, unaware of the vast ocean that stretches beyond every horizon. But here's what I find most beautiful about the multiverse concept. It doesn't diminish the significance of our existence. Instead, it places our reality within a context so grand that it defies comprehension. Even if there are infinite other versions of Earth, infinite other versions of you, this particular version, the one experiencing this moment right now, remains absolutely unique and irreplaceable. No other universe, no matter how similar, will ever contain exactly these thoughts, exactly these experiences, exactly this precise arrangement of consciousness contemplating its place in the cosmic order. The multiverse doesn't make us insignificant, it makes us miraculous. In an infinite library of realities, we represent one perfect sentence in one perfect story, surrounded by countless other perfect sentences in countless other perfect stories, all of them together, composing a work of such magnitude and beauty that our minds can barely begin to grasp its scope. There's a moment that happens countless times each day when you make a simple choice, perhaps which route to take to work, what to have for lunch, or whether to call an old friend. In our everyday experience, you choose one path, and the others simply fade away as might-have-beens. But quantum mechanics, that strange and beautiful theory that governs the behavior of atoms and light, suggests something far more extraordinary. Every possible choice you could make actually does occur, each one playing out in its own separate reality. This is the essence of what physicists call the many worlds interpretation of quantum mechanics, and it leads to the most mind-bending version of the multiverse, one where reality branches like an infinite tree, with every quantum event creating new parallel worlds, where all possible outcomes become actual realities. To understand this gentle madness, imagine that reality is like a vast river that splits at every boulder it encounters. In our classical thinking, the water chooses one channel and flows that way, leaving the other path dry. But in the quantum multiverse, the river somehow flows down both channels simultaneously, dividing into parallel streams that never again rejoin, each carrying its own complete version of reality forward through time. The branching happens at the most fundamental level of existence. Every time a radioactive atom has the possibility of decaying or not decaying, both outcomes occur, just in different realities. Every time a photon encounters a half-silvered mirror and could either pass through or reflect, it does both, creating separate worlds for each possibility. Every time any quantum system faces multiple possible futures, reality itself splits to accommodate them all. What makes this idea so dizzying is the sheer number of quantum events happening every second. Every atom in your body, every particle of light from the sun, every interaction between the countless quantum systems around you represents a moment of branching. The number of parallel worlds being created each instant is larger than astronomical. It's truly infinite, growing exponentially with each passing moment. This means that there might be parallel versions of you, where every decision you've ever made went differently. There are worlds where you chose a different career, married a different person, moved to a different city, or never existed at all because your parents never met. There are versions where history unfolded along different paths, where the dinosaurs never went extinct, where different scientific discoveries were made, where other forms of art and music and literature evolved. But here's what makes the quantum multiverse even stranger than science fiction. Harler-Bolls don't just exist as abstract possibilities. According to the mathematics of quantum mechanics, they're as real and physical as the world you experience right now. The only difference is that you happen to be conscious of this particular branch of reality rather than one of the countless others. Töthers. Sopherian denser van this spiele even delth. Some physicists find this interpretation deeply troubling, preferring to believe that quantum mechanics describes only our knowledge about reality rather than reality itself. Others embrace it as the most straightforward explanation for the bizarre behavior of particles at the smallest scales. Some physicists find this interpretation deeply troubling, preferring to believe that quantum mechanics describes only our knowledge about reality rather than reality itself. Others embrace it as the most straightforward explanation for the bizarre behavior of particles at the smallest scales. The truth is, we may never know for certain whether these parallel worlds exist, because by definition, we can never communicate with or observe them directly. Yet, there's something profoundly comforting about the quantum multiverse, isn't there? It suggests that every path you didn't take in life is being explored by another version of you somewhere else in the vast space of possibilities. Every missed opportunity, every road not traveled, every love not pursued exists somewhere in the infinite branching structure of quantum reality. This perspective can transform how we think about choice and consequence. If every decision creates new worlds where all outcomes are explored, then perhaps the weight we place on making the right choice is less important than we imagine. What matters isn't choosing the single best path through life, but being fully present and conscious in whichever reality we happen to inhabit. The quantum multiverse also offers a unique perspective on death and loss. If consciousness really does branch along with physical reality, then perhaps no experience is ever truly lost. It continues forever in some parallel world, playing out its own version of the cosmic story. Every person who has ever lived might still be living somewhere in the vast space of quantum possibilities, their stories continuing along paths we can never see, but that remain eternally real. Tonight, as you drift towards sleep, imagine all the other versions of yourself in parallel worlds, some also preparing for rest, others perhaps watching the sunrise, all of them together, exploring every possible way that consciousness can experience existence in this strange and wonderful quantum cosmos. Imagine standing before an infinite art gallery where each painting depicts a complete universe, and every conceivable way that matter and energy could be arranged is represented somewhere on those endless walls. The colors in one painting might follow different rules than in another. Perhaps gravity glows purple there, or time flows in spirals rather than straight lines. This is the landscape that string theory reveals when we ask the deepest possible question: how many different ways could a universe be constructed from the fundamental building blocks of reality? String theory, that elegant attempt to unify all forces and particles into a single mathematical framework, suggests that the familiar universe we inhabit is just one solution among an almost incomprehensibly vast number of possibilities. The theory predicts that there might be as many as 10 circumflex, 500 different ways to configure the basic parameters of reality, a number so large that if you wrote it out, it would require more digits than there are atoms in the observable universe, multiplied by itself billions upon billions of times. Each of these possible universes would be like a different musical composition played by the same cosmic orchestra. The instruments, the fundamental forces and particles might be similar, but the way they're tuned, the relationships between them, the melodies they create together, would be utterly unique. In some universes, electrons might be 1,000 times heavier than in ours, making atoms the size of footballs in chemistry completely impossible. In others, the strong nuclear force might be so weak that atomic nuclei couldn't hold together, creating realms where only hydrogen could exist. What makes this landscape particularly beautiful is that most of these possible universes would be sterile, empty places where complexity could never emerge. The parameters of physics have to be tuned with extraordinary precision for a universe to support the formation of galaxies, stars, planets, and ultimately life. It's like finding the one perfect combination on an impossibly complex cosmic lock. Most combinations lead to universes that are either too chaotic for stable structures to form or too simple for interesting chemistry to develop. But scattered throughout this vast landscape of possibilities would be islands of complexity, universes where the parameters align just right to allow for rich, evolving structures. These are the cosmic gardens where matter can organize itself into ever more sophisticated patterns, where evolution can sculpt complexity from simplicity, where consciousness can eventually emerge to contemplate its own existence. This perspective suggests that our universe isn't just one of many, but one of the extraordinarily rare many that can support observers like ourselves. We exist in what physicists call a Goldilocks zone of cosmic parameters. Not too hot, not too cold, not too chaotic, not too simple, but just right for the delicate dance of forces that makes complexity possible. Some physicists propose that this vast landscape of possibilities is actually realized somewhere in the multiverse. Perhaps eternal inflation doesn't just create bubble universes with random properties, but systematically explores every possible configuration of physical laws. In this vision, reality becomes an infinite library where every possible book of physics is not just written, but lived, where every way that matter and energy could potentially interact is playing out somewhere in the endless expansion of space and time. This raises profound questions about the nature of physical law itself. In our everyday experience, the laws of physics seem absolute and unchanging. Gravity always attracts, light always travels. At the same speed, electrons always carry the same charge. But the string theory landscape suggests that these might not be laws at all, but rather local customs, accident features of our particular cosmic neighborhood that could be completely different in other regions of the multiverse. Yet even if our familiar physics is just one melody among infinite cosmic compositions, there's something deeply meaningful about finding ourselves here, in this particular arrangement of possibilities. The fact that we can contemplate the landscape of potential realities means that consciousness itself is one of the most remarkable emergent properties that any universe can develop. We are, quite literally, the cosmos awakening to its own vast potential. As you rest tonight, surrounded by the gentle darkness of this particular universe, with its particular laws and possibilities, remember that you represent something extraordinarily rare and precious, a configuration of matter and energy that has learned to wonder about all the other configurations that might exist in the infinite space of cosmic possibility. You are one perfect note in the grandest symphony ever composed. Picture yourself as an intrepid explorer from the 15th century, determined to find the edge of the world. You've heard tales that if you sail far enough across the ocean, you'll eventually reach a place where the water simply ends, perhaps cascading into an infinite void, or blocked by an enormous wall that marks the boundary between existence and nothingness. So you set sail with your bravest crew, heading toward what you believe must be the ultimate horizon. But then, something strange happens. No matter how far you travel, the horizon keeps receding before you. Days turn to weeks, weeks to months, and still you find nothing but more ocean stretching endlessly ahead. Eventually, if you're persistent and fortunate enough, you might find yourself approaching familiar shores from an unexpected direction. Having discovered that the Earth has no edge at all, it simply curves back on itself in a way that makes every point simultaneously a potential center and a potential boundary. This gentle story captures one of the most profound puzzles we face when trying to understand what lies beyond the edge of the universe. The question itself might be fundamentally flawed, like asking what's north of the North Pole, or what happened before the beginning of time. When we probe the meaning of beyond in a cosmic context, we quickly discover that our everyday language and intuition are woefully inadequate for the task. Think about what we actually mean when we say beyond. In our daily experience, beyond always refers to a space or region that exists outside of something else. Beyond the garden lies the forest. Beyond the forest lies the mountains. Beyond the mountains lies the sea. But this concept assumes the existence of a larger container, a more expansive space within which both the original thing and the beyond can coexist. When we ask what lies beyond the universe, we're implicitly assuming that the universe exists within some larger space, like a cosmic snow globe sitting on an infinite table. But what if the universe isn't contained within anything? What if it is the totality of all space, all time, all existence itself? In that case, asking what lies beyond it is like asking what's outside of outside, a question that dissolves into meaninglessness the moment we examine it carefully. This linguistic puzzle reveals something profound about the limits of human cognition. Our brains evolved to navigate a world of objects within spaces, of containers and contained, of here and there and beyond. We're exquisitely adapted to think about boundaries, because boundaries were matters of life and death for our ancestors. The boundary between safe and dangerous territory, between food and poison, between friend and foe. But the universe doesn't necessarily conform to these categories that served us so well on the African savanna. It might be boundaryless, not because it extends infinitely in all directions, but because the very concept of a boundary becomes meaningless when applied to the totality of existence. It's like trying to find the boundary of the number line. No matter how far you count, there's always another number, not because the line extends into some meta-mathematical space, but because number is the space within which counting occurs. Consider another puzzle. If the universe does have an edge, what would that edge be made of? Would it be a wall of some exotic material, a membrane separating our reality from another? But any such barrier would itself be part of physical reality, part of the universe we're trying to bound. It's like trying to build a fence around all of existence using materials that are themselves part of existence. A logical paradox that leads us in circles. Perhaps the most beautiful aspect of this paradox is how it humbles our pretensions to ultimate understanding. We are finite beings, evolved to survive in a local environment, attempting to comprehend the infinite and absolute. It's not surprising that our language breaks down, that our concepts prove inadequate, that our questions themselves become part of the mystery rather than pathways to answers. This doesn't mean we should stop asking these questions. Rather, it suggests that the value of the question, what lies beyond the edge of the universe, might not be in finding a definitive answer, but in discovering the limits of questioning itself. In pushing our concepts to their breaking point, we learn something profound about the nature of existence, knowledge, and the beautiful inadequacy of human understanding when faced with the ultimate mystery of why there is something rather than nothing at all. Close your eyes and try to imagine nothingness, not darkness, not empty space, not silence, but true nothingness. No space for darkness to fill, no time for silence to occupy, no framework within which even the concept of absence could exist. It's impossible, isn't it? The moment you try to picture nothing, you create a mental space within which that nothing can be imagined. And suddenly you're no longer imagining true nothingness at all. This little thought experiment reveals something profound about the nature of space and time themselves, and why the question of what lies beyond the universe becomes so beautifully perplexing. When we ask what exists beyond the cosmic edge, we're unconsciously assuming that space and time, the stage upon which all existence plays out, extend beyond the universe itself. Whole. But what if space and time aren't the stage? What if they're part of the performance? Einstein's greatest insight was recognizing that space and time aren't fixed, eternal backdrops against which events unfold. Instead, they're dynamic, malleable aspects of reality that can stretch, compress, curve, and even begin or end. Space-time is not the container within which the universe exists. It is part of the universe itself, as much a physical entity as matter and energy, intimately woven together with them in ways that our everyday experience cannot even hint at. This means that when the universe began, in that moment we call the Big Bang, it wasn't an explosion that happened within pre-existing space and time. It was the emergence of space and time themselves. This means that when the universe began, in that moment we call the Big Bang, it wasn't an explosion that happened within pre-existing space and time. Before that moment, The very concepts of before, location, duration, and distance had no meaning because the framework that gives these concepts their significance didn't yet exist. Think of it like the emergence of a musical composition. Before the first note is played, there's no musical time within which silence exists. There's simply no temporal framework of rhythm and meter within which musical events can occur. The composition doesn't unfold within pre-existing musical time. It creates musical time as it unfolds. Similarly, the universe doesn't expand into pre-existing space. It creates space as it expands. This perspective transforms our understanding of cosmic boundaries. If space itself is part of the universe, then asking what lies beyond the edge of space becomes as meaningless as asking where you were before you were born. The question assumes a framework, a where and a when, that only comes into existence with the very thing we're trying to place within it. But here's where it becomes even more mysterious and beautiful. Some versions of modern cosmology suggest that space and time themselves might emerge from something even more fundamental, perhaps from pure information, or from the quantum mechanical relationships between possibilities, or from mathematical structures so abstract that calling them things at all might be misleading. In these theories, space and time are like the melody that emerges when an infinitely complex cosmic symphony is played, or like the pattern that appears when an unimaginably vast cellular automaton follows its simple rules for countless iterations. They're not fundamental features of reality, but emergent properties of deeper, more abstract processes that our minds can barely begin to grasp. This raises the profound possibility that existence itself might not require space and time as we understand them. Perhaps what we experience as the cosmos, with its galaxies and stars, its past and future, its here and there, is just one possible manifestation of something far more abstract and mathematical. Other manifestations might involve entirely different ways of organizing experience, different frameworks for what we might generously call existence, though even that word might be inadequate. What moves me most about these ideas is how they dissolve the boundary between the physical and the metaphysical, between science and philosophy, between what is and what could be. They suggest that the deepest questions about reality aren't questions about things, but questions about the nature of existence itself. Not what exists, but what it could possibly mean for anything to exist at all. As you drift towards sleep tonight, suspended in this moment between waking and dreaming, you're floating in space-time itself, carried along by the expansion of the cosmos, participating in the vast, ongoing process by which abstract mathematical relationships somehow give rise to the vivid, immediate reality of conscious experience. You are not just in the universe. You are one of the ways the universe has learned to experience itself from within the very space and time it creates. Imagine holding two photographs in your hands. The first shows a perfect circle, complete and bounded, every point on its circumference equidistant from the center, beautiful in its completeness, elegant in its finitude. The second photograph is impossible to hold because it never ends, showing a landscape that stretches infinitely in every direction, containing every possible variation of mountain and valley, forest and desert, all arrangements that could ever be imagined, extending forever beyond every horizon. These two images represent perhaps the most profound question we can ask about our cosmic home. Is the universe finite or infinite? The answer shapes not just our understanding of physics and cosmology, but our deepest philosophical intuitions about meaning, purpose, and the nature of existence itself. If the universe is finite, bounded, complete, containing a specific amount of matter and energy arranged in particular ways, then there's something almost comforting about our cosmic situation. We exist within a whole, a complete story that has definite chapters and perhaps even an ending. Every particle, every star, every galaxy is part of a single unified system. There's a total inventory of everything that exists. And while that inventory might be unimaginably vast, it's not unlimited. In such a universe, rarity has meaning. Each configuration of matter, each moment of consciousness, each experience of beauty or love represents something genuinely unique and irreplaceable. But if the universe is infinite, extending forever in space and perhaps containing unlimited amounts of matter and energy, then our philosophical landscape shifts dramatically. In an infinite cosmos, everything that can happen, and must happen infinitely often. Every possible arrangement of atoms, every conceivable form of life, every potential work of art or music or literature must exist somewhere in the endless expanse of space and time. This infinite perspective can feel either liberating or terrifying, depending on how you approach it. On one hand, it means that every dream you've never pursued, every path you didn't take, every possibility you've wondered about, is actually realized somewhere else in the cosmic vastness. There are infinite versions of Earth, where every extinct species still thrives, where every war was avoided, where every tragedy became a triumph. Nothing is ever truly lost, because everything that could be is. But infinity also raises profound questions about meaning and significance. If everything possible actually exists, then what makes any particular thing special? If there are infinite versions of you making every possible choice, experiencing every conceivable outcome, then what's the significance of the choices you make in this particular version of reality? Does individual agency matter in a cosmos where every possible action is simultaneously being taken by some version of you? Perhaps the most unsettling implication of infinity is how it challenges our notions of achievement and progress. If every possible configuration of matter exists somewhere, then every possible work of art has already been created. Every possible scientific discovery has already been made. Every possible act of love or kindness has already been performed. We become not creators, but discoverers, not pioneers, but echoes of infinite variations that stretch across the endless cosmos. Yet there's another way to think about infinity that I find deeply beautiful. Even in an infinite universe where everything possible exists, the particular configuration of matter and energy that gives rise to your consciousness, your experiences, your unique perspective on existence remains absolutely precious. Yes, there might be infinite versions of you, but none of them are experiencing exactly this moment, having exactly these thoughts, feeling exactly this sense of wonder at the mystery of existence. The question of finite versus infinite also connects to our deepest spiritual and existential longings. A finite universe offers the comfort of completeness, but also the melancholy of limitation, the knowledge that there are things that will never be, experiences that will never occur, possibilities that will remain forever unexplored. An infinite universe offers the joy of unlimited possibility, but also the vertigo of boundlessness. The realization that our familiar concepts of uniqueness and significance dissolve in the face of endless repetition and variation. Perhaps the most profound implication is that either answer, finite or infinite, reveals the universe to be far stranger and more wonderful than our everyday experience suggests. Whether we live in a bounded whole or an endless exploration, we find ourselves in a reality that transcends our ability to fully comprehend it. In either case, we are part of something so magnificent that our minds can barely begin to grasp its true nature, and that recognition itself might be the most meaningful response we can have to the cosmic mystery that surrounds us. Picture the universe as a vast orchestra, and for nearly 14 billion years, you've been listening to a symphony played in a particular key. The stately, predictable music of cosmic expansion, gradually slowing down under the gentle break of gravity. Galaxies have been moving apart from each other since the Big Bang, but like a ball thrown into the air, their recession should be slowing as gravity tugs them back together. This was the melody cosmologists expected to hear when they first tried to measure the expansion rate of the universe in the 1990s. But then something extraordinary happened. When astronomers looked at distant supernovae, those cosmic lighthouses we discussed earlier, they discovered that the universe's expansion isn't slowing down at all. Instead, it's speeding up, accelerating, as if some invisible force is actively pushing space itself apart with ever-increasing vigor. It was like discovering that the ball you threw into the air, instead of falling back down, had suddenly begun rocketing upward with increasing speed. This discovery was so unexpected, so contrary to everything physicists thought they understood about cosmic evolution, that the scientific community initially greeted it with skepticism. Teams of researchers double-checked their measurements, looked for errors in their calculations, searched for alternative explanations. But the evidence kept pointing to the same startling conclusion. Something is causing the expansion of space to accelerate, and we have no idea what it is. This mysterious something has been given the name dark energy, though the name tells us more about our ignorance than our understanding. It's not dark in the sense of being shadowy or sinister. It's dark in the sense of being completely invisible to all our instruments, except for its gravitational effects. And it's not energy in any familiar sense either. Unlike the energy stored in gasoline or sunlight, or the motion of planets, dark energy doesn't seem to diminish as it does work. The more it stretches space, the more space it has to work with, and somehow it maintains its strength across the expanding cosmos. It's not in cosmos, distranding cosmos. Think of it this way. Imagine trying to pull apart two magnets, and as you separate them, instead of the force getting weaker, it somehow stays constant or even grows stronger. That's what dark energy appears to do to space itself. The more the universe expands, the more dark energy there is to drive further expansion. It's as if empty space itself possesses an inherent springiness, an intrinsic tendency to create more of itself. What makes dark energy even more mysterious is its sheer dominance. When astronomers add up all the matter and energy in the universe, they find that dark energy comprises about 68% of everything that exists. The familiar matter that makes up stars, planets, and people accounts for less than 5% of the cosmic inventory. We are, quite literally, minority constituents in a universe dominated by something we cannot see, touch, or even begin to understand. The discovery of dark energy has profound implications for our understanding of empty space itself. We tend to think of vacuum as nothing, the absence of matter and energy. But dark energy suggests that even the most perfect vacuum is actually seething with invisible activity, filled with energy that manifests itself only on cosmic scales. Every cubic meter of empty space contains the same amount of dark energy, creating a kind of cosmic pressure that pushes against the gravitational attraction between galaxies. Some physicists speculate that dark energy might be connected to the quantum vacuum, the idea that even empty space is filled with virtual particles constantly popping into and out of existence. Others propose that it represents a fundamental property of space-time itself, a kind of cosmic constant that Einstein once introduced into his equations and later called his greatest blunder. Ironically, Einstein's blunder might turn out to be one of his most prescient insights. Ideas were Version, Ideation, Insertion, Descher. What strikes me as most beautiful about dark energy is how it transforms our perception of emptiness itself. The vast spaces between galaxies, which seem so barren and lifeless, are actually the most energetic regions of the cosmos, filled with the mysterious force that's shaping the ultimate destiny of everything that exists. These cosmic voids aren't empty at all. They're the engine rooms of cosmic evolution, the places where the future of the universe is being written in a language we're only beginning to learn how to read. Tonight, as you rest in what seems like the stillness of your quiet room, remember that you're surrounded by this same dark energy, gently pushing against the very fabric of space, carrying you along on the grandest journey of all, the accelerating expansion of existence itself. Imagine standing on the shore of an infinite ocean, watching the tide go out. At first, it recedes slowly, predictably, leaving behind familiar tidal pools and exposed rocks. But then something strange begins to happen. The retreat accelerates, the water pulling back faster and faster, revealing landscapes you never knew existed beneath the waves. Eventually, the ocean retreats so far and so fast that even the horizon itself begins to recede, carrying with it everything you once thought was permanent and unchanging. This is perhaps the gentlest way to visualize what dark energy might be doing to our cosmic future. The accelerating expansion it drives isn't just making galaxies move apart more quickly, it's fundamentally altering the destiny of everything that exists, writing the final chapters of the cosmic story in ways that would have seemed unimaginable just a few decades ago. In the traditional picture of cosmic evolution, the universe faced essentially two possible fates. If there was enough matter and energy to overcome the expansion, gravity would eventually win, causing everything to collapse back together in a mirror image of the Big Bang, what cosmologists poetically called the Big Crunch. Alternatively, if expansion proved stronger than gravity, the universe would expand forever, but gradually slow down, eventually reaching a state of maximum entropy, where all the stars had died and all the black holes had evaporated, leaving only isolated particles drifting through an increasingly cold and empty cosmos. But dark energy introduces a third possibility that's far more dramatic than either of these scenarios. If the acceleration continues, and all current evidence suggests it will, then we're heading toward what cosmologists call the Big Rip, a future where space itself expands so rapidly that it eventually overcomes not just gravity, but all the fundamental forces that hold matter together. Picture this cosmic finale unfolding over billions of years. At first, the acceleration would be barely noticeable on human timescales. Galaxies would continue to drift apart, but within our local cluster, gravity would still bind things together, much as they are today. The Milky Way and Andromeda would still collide and merge as predicted, creating a single massive elliptical galaxy in an increasingly lonely cosmic neighborhood. But as eons pass and the expansion accelerates further, even these gravitationally bound clusters would begin to feel the effects. Galaxies would be pulled apart, their spiral arms unwinding as dark energy overcomes the gravity that once held them in their elegant formations. Stars would be scattered like leaves in an increasingly violent cosmic wind, drifting alone through expanding space. If the acceleration continues to strengthen, even more intimate structures would eventually succumb. Solar systems would be torn apart as the expansion of space overwhelms the gravitational bonds between stars and planets. Eventually, even planets themselves would be pulled apart as dark energy conquers the forces that hold rock and metal together. In the final moments of this cosmic dissolution, atoms themselves would be ripped apart, their electrons stripped away from their nuclei by the sheer violence of expanding space. But here's what I find both sobering and strangely comforting about these far future scenarios. They're so distant in time that they exist in a realm almost beyond meaningful contemplation. The Big Rip, if it occurs at all, wouldn't happen for at least 22 billion years, longer than the current age of the universe. Stars will shine, planets will form, life will evolve, civilizations will rise and fall, countless times before space itself becomes hostile to the existence of complex structures. Moreover, these predictions assume that dark energy remains constant or continues to strengthen, but we understand so little about dark energy that it's entirely possible its behavior could change. Perhaps it will weaken over time, allowing gravity to regain influence over cosmic evolution. Perhaps it represents a phase transition, like water turning to steam, and the universe will eventually enter a completely different mode of expansion. Perhaps other forces or fields we haven't yet discovered will come into play, altering the cosmic script in ways we cannot currently imagine. What moves me most about contemplating these cosmic futures is how they illuminate the preciousness of the present moment. Right now, we exist in a universe perfectly balanced between creation and destruction, where stars are still forming, where planets can harbor life, where consciousness can emerge to contemplate the mystery of existence itself. We live in a cosmic sweet spot, a brief window in the history of everything, when complexity and beauty and awareness are not just possible but abundant. The accelerating expansion reminds us that nothing in the cosmos is permanent, but also that impermanence itself makes every moment, every experience, every fleeting arrangement of matter and energy infinitely precious. Think of yourself as a lighthouse keeper on a small island, watching ships disappear over the horizon. In normal circumstances, you might expect that with a powerful enough telescope, you could see farther and farther, eventually observing ships that are incredibly distant, but still, in principle, visible. But now imagine that the ocean itself is expanding, carrying those ships away from you at an accelerating rate. Eventually, ships that are far enough away would be receding so quickly that their light could never reach you, no matter how long you waited or how powerful your telescope became. This is precisely what dark energy is doing to our cosmic lighthouse. The accelerating expansion of space isn't just making distant galaxies move away from us more quickly. It's fundamentally changing which parts of the universe we can ever hope to observe, creating new kinds of cosmic boundaries that are even more absolute than the ones we've explored so far. Our observable universe, that sphere of space from which light has had time to reach us since the Big Bang, is currently about 46.5 billion light-years in radius. You might expect this boundary to keep expanding as time passes, allowing us to see ever more distant regions of space as their light finally completes its journey to Earth. And indeed, without dark energy, this is exactly what would happen. Our cosmic horizon would gradually expand, revealing more and more of the universe as it aged. But dark energy changes this story in a profound way. While space expands everywhere, the effect becomes dominant only on the largest scales, where the cumulative stretching across vast distances can overcome the gravitational attraction between galaxies. There's a distance currently about 16 billion light-years away, beyond which galaxies are receding from us faster than the speed of light due to the expansion of space itself. This creates what cosmologists call the cosmic event horizon, and it's even more isolating than our current observable boundary. Light emitted right now from galaxies beyond this horizon will never reach us, no matter how long we wait. The expansion of space will always stretch that light farther away faster than it can approach us. These regions of the universe are becoming causally disconnected from us, drifting into a realm of space-time that can never again influence our cosmic neighborhood in any way. What makes this particularly poignant is that this event horizon is actually shrinking. As the expansion accelerates, the boundary between the reachable and unreachable portions of the universe moves inward, encompassing fewer and fewer galaxies. We are watching the cosmic neighborhood contract around us, not because we're moving anywhere, but because the very fabric of space is carrying distant regions beyond the reach of any possible communication or influence. In fact, if dark energy continues to dominate cosmic evolution, our descendants billions of years from now will inhabit a much lonelier universe than we do today. They'll be able to observe only the galaxies in our local cluster, the Milky Way, Andromeda, and a few dozen smaller companions that are gravitationally bound together strongly enough to resist the cosmic expansion. Everything else will have disappeared beyond their cosmic horizon, leaving them in a universe that appears much smaller and more isolated than the rich galaxy-filled cosmos we see today. This has profound implications for the future of astronomy and our understanding of cosmic history. Future civilizations might look out at their local cluster, surrounded by empty space, and have no way to deduce that there was once a much larger, more diverse universe filled with billions of other galaxies. The evidence for the Big Bang, for cosmic inflation, for the large-scale structure of the universe, all of it will have been carried beyond the reach of observation. From their perspective, the universe might appear static and eternal, centered on their small collection of gravitationally bound galaxies. They would be like astronomers trapped on a slowly shrinking island, watching their cosmic laboratory disappear piece by piece into an expanding ocean of inaccessible space. Yet there's something beautifully democratic about this cosmic isolation. Every gravitationally bound region of the universe will eventually find itself in the same situation, surrounded by its own small collection of companion galaxies in an otherwise empty cosmos. Each region will become its own isolated universe, complete and self-contained, carrying forward its own version of the cosmic story. This perspective transforms our understanding of what lies beyond the edge of the universe. The answer might not be more space or other dimensions, but simply regions of our own universe that have become forever unreachable, existing in the same space-time as us, but separated by the ultimate barrier, the accelerating expansion of space itself. Imagine you're a character living in a beautiful painting, not painted on the surface, but somehow existing within the two-dimensional world of the canvas itself. From your perspective within this flat realm, you can move forward and backward, left and right, but the very concept of up and down in the third dimension is completely foreign to you. You might be aware that your 2D world curves and bends in subtle ways, but you couldn't possibly visualize or understand that your entire reality might be wrapped around the surface of a sphere floating in a three-dimensional space you cannot perceive. This gentle thought experiment touches on one of the most mind-bending possibilities for what might lie beyond our cosmic boundaries. Perhaps our entire three-dimensional universe, with all its galaxies and dark matter and expanding space, is actually embedded within a higher dimensional realm that we cannot directly perceive or access. Just as that 2D character could never step off the canvas to see the 3D room containing it, we might be forever confined to moving through the 3 dimensions of space and 1 dimension of time that define our cosmic home, unaware of additional spatial dimensions that curve and fold around us in ways our minds cannot visualize. This idea emerges naturally from some of our most sophisticated theories of physics. String theory, that elegant attempt to unify quantum mechanics with gravity, suggests that reality might actually have 10 or 11 dimensions, most of which are hidden from our everyday experience. These extra dimensions might be curled up so tightly that they're invisible at the scales we can observe, or they might extend infinitely while remaining somehow inaccessible to the matter and energy that makes up our familiar world. In some versions of these theories, our entire universe, everything we can see or could ever hope to see, exists as a kind of membrane or brain floating within this higher dimensional space. The expansion of our universe wouldn't be expansion into empty space as we normally imagine it, but rather the stretching and growing of this cosmic membrane within the larger dimensional arena that contains it. When there's membrane within the larger dimensional arena that contains it. When there's membrane, when there's membrane, when there's membrane, sequin burst of siebing zikri. Think of it like a soap bubble expanding in air. From the perspective of a microscopic creature living on the bubble's surface, the bubble's expansion might seem like the creation of new surface area from nothing. But from our 3D perspective, we can see that the bubble is simply growing larger within the pre-existing three-dimensional space that surrounds it. Similarly, our expanding universe might be growing within pre-existing higher dimensional space that we cannot perceive. This perspective offers fascinating possibilities for what might exist beyond our cosmic boundaries. Other cosmic membranes might float nearby in this higher dimensional space, parallel universes that share the same dimensional arena but remain forever inaccessible to us because matter and energy cannot travel between branes. These parallel worlds might have completely different physical laws, different numbers of spatial dimensions, different arrangements of forces and particles. Occasionally, these cosmic membranes might even interact. Some cosmologists have proposed that the Big Bang itself might have been the result of a collision between our cosmic brain and another one floating nearby in higher dimensional space. The enormous energies released by such a collision could have triggered the rapid expansion and heating that we observe in our universe's earliest moments. What I find most beautiful about the embedded universe hypothesis is how it resolves the paradox of cosmic boundaries while preserving the mystery. If our universe is embedded in higher dimensional space, then it can be finite without having an edge, just as the surface of a sphere is finite but boundaryless when viewed from within the 2D surface itself. The universe wouldn't end at some cosmic wall. It would simply curve back on itself through dimensions we cannot perceive. Yet this resolution comes with its own profound mysteries. What is the nature of this higher dimensional space? How many other cosmic membranes might exist within it? Could there be entire hierarchies of embedded realities, with our universe existing within a higher dimensional space? It itself exists within an even higher dimensional realm. The embedded universe hypothesis also raises questions about the fundamental nature of physical law. If our familiar physics is confined to our particular cosmic membrane, then the deeper laws governing the higher dimensional space might be utterly alien to anything we could understand or experience. We might be like flatlanders trying to comprehend the physics of three-dimensional space, capable of observing the effects, but fundamentally limited in our ability to grasp the underlying reality. Tonight, as you rest in what seems like familiar three-dimensional space, remember that you might actually be floating on the surface of a cosmic membrane, embedded within dimensional realms so vast and strange that even our boldest imagination can barely begin to hint at their true nature. Picture yourself watching a movie in a theater, completely absorbed in the story unfolding on the screen. The characters seem three-dimensional, the landscapes have depth and perspective, yet you're aware that everything you're seeing is actually encoded as patterns of light on a flat, two-dimensional surface. All the information needed to create the illusion of depth, motion, and complexity is somehow compressed into the theater screen itself. This everyday experience hints at one of the most revolutionary ideas in modern physics, holographic principle, which suggests that our entire three-dimensional universe, with all its depth and complexity, might actually be encoded as information on a two-dimensional surface, like the ultimate cosmic movie screen surrounding everything we know. The idea emerged from studies of black holes, those mysterious regions where gravity becomes so strong that not even light can escape. When physicists calculated how much information a black hole can contain, they discovered something startling. The maximum amount of information depends not on the black hole's volume, as you might expect, but on the area of its surface. It's as if all the information about everything that has ever fallen into the black hole is somehow stored on its two-dimensional boundary. This discovery led to a profound realization. Perhaps the relationship between information, area, and volume that we observe in black holes applies to the entire universe. Maybe all the information that describes our three-dimensional reality, every particle, every field, every quantum state, is actually encoded on a distant two-dimensional boundary, like data stored on the surface of an enormous cosmic sphere. Think of it this way. Imagine you're living inside a vast hologram. Everything you experience as solid, three-dimensional reality would actually be the projection of information patterns stored on the hologram's surface. The hologram wouldn't be an illusion or approximation of reality. It would be reality, just organized in a way that's fundamentally different from how it appears to us. This perspective transforms our understanding of what the universe might be expanding into. Instead of expanding into higher dimensional space or creating new volume from nothing, the universe might be like a hologram that's becoming more detailed, with the information on its boundary surface becoming richer and more complex over time. Its perspective transforms our understanding of what the universe might be expanding into. The expansion we observe might not be the creation of new space, but rather the unpacking of information that was always encoded on the cosmic boundary. What makes this idea even more mind-bending is that it suggests the boundary of our universe might contain exactly the right amount of information to describe everything within it. Every star, every planet, every thought you've ever had, every possible quantum state that has ever existed or ever could exist. We would be, quite literally, characters in a cosmic story written on the surface of reality itself. The holographic principle also offers a new perspective on the question of what lies beyond our cosmic boundaries. If our three-dimensional reality is a projection from a two-dimensional surface, then beyond might not refer to additional space, but to additional layers of information, encoding other realities, other possible worlds, other ways of organizing the fundamental data of existence. Some versions of this idea suggest that what we experience as the passage of time might actually be the sequential reading of information from the cosmic boundary, like frames of a movie being projected one after another. The future wouldn't exist in some distant region of space-time, but would be encoded as potential information patterns waiting to be activated on the universal hologram. This raises profound questions about the nature of consciousness itself. If our entire reality is information encoded on a distant boundary, then our thoughts, our experiences, our sense of being aware observers in a three-dimensional world might all be emergent properties of information processing on that cosmic surface. We might be patterns of information that have achieved sufficient complexity to become self-aware, conscious algorithms running on the ultimate computer, the boundary of the universe itself. What I find most beautiful about the holographic principle is how it suggests that information, not matter or energy, might be the most fundamental aspect of reality. Everything we experience, the warmth of sunlight, the scent of flowers, the feeling of love, The wonder of contemplating the cosmos might ultimately be different ways that information can organize itself into patterns complex enough to experience their own existence. As you settle into sleep tonight, consider this possibility. You might be a beautiful arrangement of information on the surface of reality, dreaming yourself into three-dimensional existence, participating in the universe's ongoing project of transforming abstract data into lived experience, conscious awareness, and the capacity to wonder about the deeper nature of what it means to exist at all. Imagine looking at the surface of a calm lake from high above. From your airplane window, the water appears perfectly smooth, a flawless mirror reflecting clouds and sky. As you descend closer, you begin to notice small ripples, gentle waves disturbing the surface. Lower still, you might see the wake from a passing boat, the splash of a jumping fish. And if you could somehow dive down to examine the water at a molecular level, you would discover that even the seemingly stillest water is actually in constant motion, with individual molecules dancing and colliding in endless thermal chaos. This gentle analogy helps us approach one of the most profound ideas in physics, that space and time themselves, which appear smooth and continuous in our everyday experience, might actually be seething with activity at the smallest possible scales. Just as water appears calm from a distance, but reveals increasing turbulence as we examine it more closely, the fabric of space-time might become increasingly chaotic as we probe toward the fundamental limits of reality. At the scale of everyday experience, space-time behaves much like Einstein described it, a smooth, continuous fabric that can be curved by matter and energy, stretched by cosmic expansion, rippled by gravitational waves. But physicists have long suspected that if we could somehow zoom in to distances smaller than anything we can currently measure, smaller than atoms, smaller than atomic nuclei, smaller even than the fundamental particles, we would discover that space-time itself breaks down into something far stranger and more dynamic. This realm is called the Planck scale, named after the physicist Max Planck, and it represents the distance at which quantum mechanics and gravity become equally important in describing physical phenomena. At this scale, approximately 10 circumflex 35 meters, unimaginably smaller than anything we've ever observed, space and time might not exist as smooth dimensions, but as a kind of quantum foam, a roiling sea of virtual particles and fluctuating energy that constantly creates and destroys tiny regions of space-time itself. Picture this quantum foam as being like the static on an old television set, but instead of random dots of light and shadow, imagine random bits of space and time flickering in and out of existence. Virtual black holes might form and evaporate. Wormholes might open and close. The very geometry of space might fluctuate wildly between different possible configurations. At these scales, the familiar notions of distance, duration, and causality might dissolve into a kind of fundamental uncertainty that governs the deepest level of reality. This quantum foam might hold the key to understanding what lies beyond the boundaries of our universe. If space-time itself emerges from this deeper quantum substrate, then the expansion of the universe might not be expansion into pre-existing space, but rather the ongoing crystallization of space-time from the quantum foam, like ice crystals forming from supercooled water, creating ordered structure from chaotic motion. In this view, the edge of our universe might be the boundary between the ordered space-time we inhabit and the primordial quantum foam from which it continues to emerge. Beyond our cosmic boundaries might lie not empty space or higher dimensions, but the seething quantum uncertainty from which all space, time, matter, and energy ultimately arise. Some physicists have proposed that this quantum foam might be far richer and more complex than we imagine. Like different regions of the foam might crystallize into spacetimes with different numbers of dimensions, different physical laws, different ways of organizing matter and energy. Our familiar 3 dimensions of space and 1 dimension of time might be just one possible way that the quantum foam can organize itself into coherent reality. This perspective suggests that the question, what lies beyond the edge of the universe, might be fundamentally unanswerable, because it assumes that beyond has meaning in the context of space and time, when space and time themselves might be emergent properties of something more fundamental. It's like asking what lies north of the North Pole. The question dissolves because it tries to apply directional concepts beyond their domain of validity. Yet there's something deeply beautiful about the idea that our entire cosmos, with all its galaxies and stars and the consciousness that contemplates them, might be a single crystallization event in an infinite ocean of quantum possibility. We might be like snowflakes forming in a cosmic blizzard, each one unique and temporary, each one a brief organization of deeper chaotic processes into patterns beautiful enough to sustain complexity, life, and awareness.
Cheerio.
Tonight, as you rest in what seems like solid, reliable space-time, remember that at the deepest level, you might be floating on quantum foam itself, sustained by the dance of virtual particles, carried by fluctuations in the very fabric of reality, participating in the ongoing miracle by which chaos somehow organizes itself into the stable structures that make consciousness possible. There's a moment that comes to every thoughtful person, usually in the quiet darkness before dawn or in the peaceful pause before sleep, when you realize that no matter how much you learn, no matter how many books you read, or conversations you have, or insights you gain, there will always be more mystery than understanding, more questions than answers, more wonder than knowledge. This isn't a failure of education or imagination. It's the fundamental condition of being a conscious observer in an infinite cosmos. As we've journeyed together through these cosmic mysteries tonight, exploring the edges of observable reality and the boundaries of theoretical possibility, we've arrived at something both humbling and beautiful, the recognition that some questions might not just be difficult to answer, but impossible to answer, not because of limitations in our instruments or intelligence, but because of the very nature of existence itself. Consider what we've discovered about the observable universe, that sphere of space and time from which information can reach us. Beyond its boundaries lie regions that are not just currently invisible, but permanently, absolutely unknowable. Even if we possessed infinite time and infinitely sophisticated technology, even if we became beings of pure intelligence with perfect understanding of every physical law, we could never directly observe what lies beyond that cosmic horizon. The speed of light and the expansion of space create an ultimate limit to knowledge that no amount of cleverness can circumvent. This absolute boundary to observation means that certain questions about the universe's true extent, its ultimate fate, its deepest nature, might remain forever unanswered. We can theorize, we can extrapolate, we can build mathematical models of extraordinary sophistication, but we can never step outside our cosmic sphere to see the whole picture from an external perspective. We are forever interior to the mystery we're trying to solve, like characters in a story attempting to understand the nature of the book that contains them. The multiverse theories we've explored offer another example of beautiful unknowability. If infinite parallel realities exist, whether through quantum branching, eternal inflation, or string theory's vast landscape of possibilities, then by definition, most of them remain forever beyond our reach. We might exist in a cosmos of infinite richness and possibility, but we can only ever experience one small thread in the vast tapestry of what might be. Even our most successful physical theories point toward their own limitations. Quantum mechanics reveals a fundamental uncertainty at the heart of reality, suggesting that perfect knowledge of any system is not just practically difficult but theoretically impossible. Einstein's relativity shows us that space and time themselves are relative, observer-dependent concepts, making it unclear whether questions about absolute simultaneity or universal now even have meaningful answers. Perhaps most profoundly, consciousness itself remains deeply mysterious. Despite all our advances in neuroscience and cognitive psychology, we still don't understand how subjective experience emerges from objective physical processes. If in P6, I know T-amendur of P6, with the main T-amendur of P6. The very awareness that allows you to contemplate these cosmic mysteries, the consciousness that makes you you, remains as puzzling as any distant galaxy or exotic particle. We are the instruments of cosmic self-awareness, yet we don't fully understand how we work. But here's what I find most beautiful about these limitations. They don't diminish the value of inquiry, they enhance it. Knowing that some mysteries may never be solved doesn't make science pointless. It makes every genuine discovery more precious. Each new understanding becomes a small miracle, a brief moment when the cosmos reveals one of its secrets to finite minds, evolved on a small planet orbiting an ordinary star. The permanent presence of mystery also preserves something essential to human experience: wonder. A universe that we could completely understand would be a universe without surprise, without the possibility of revelation, without the deep joy that comes from encountering something genuinely new and unexpected. Mystery isn't the opposite of knowledge. It's knowledge's eternal companion, ensuring that no matter how much we learn, there will always be more to discover. This perspective transforms how we might think about the ultimate questions. Instead of being frustrated by their possible unanswerable, we can appreciate them as invitations to deeper contemplation, as koans that point toward truths too large for any finite mind to fully grasp. Girieth. Fulifer. The question, what lies beyond the edge of the universe, might be valuable not because it has a definitive answer, but because asking it stretches our imagination toward the infinite, connects us to the fundamental mystery of existence, and reminds us of our place in something unimaginably vast and beautiful. Tonight, as you prepare to dream, let yourself feel grateful for living in a cosmos mysterious enough to inspire such questions, complex enough to reward investigation, and vast enough to ensure that wonder will never be exhausted. There's something transformative that happens when you truly contemplate the question of what lies beyond the edge of everything. It's not just an intellectual exercise or a curious puzzle to be solved. It's a journey that changes the traveler, reshaping how you see yourself, your relationships, your daily concerns, and your place in the vast cosmic story that surrounds us all. When you first begin to grasp the sheer scale of the observable universe, 46.5 billion light-years in every direction, containing hundreds of billions of galaxies, each with hundreds of billions of stars, something shifts in your perspective. The problems that seemed so large and pressing this morning begin to seem smaller, not because they matter less, but because they exist within a context so vast that it provides a kind of gentle comfort. You realize that your worries, like yourself, are temporary patterns in an unfolding cosmic dance that has been going on for nearly 14 billion years and will continue for eons beyond your wildest imagination. But then comes an even deeper shift. As we've explored together tonight, the observable universe itself might be infinitesimally small compared to what actually exists. If the multiverse theories are correct, if eternal inflation continues beyond our cosmic horizon, if parallel realities branch from every quantum event, then our entire visible cosmos becomes not just small, but infinitely small, a single point of awareness in an ocean of infinite possibility. This realization can be initially overwhelming, even frightening. How can individual human life have meaning in such an incomprehensibly vast context? But if you sit with this feeling long enough, something beautiful happens. You begin to realize that meaning doesn't come from size or permanence. It comes from relationship, from consciousness, from the capacity to love and wonder and create beauty in whatever context you find yourself. The question of cosmic boundaries also transforms how we think about connection and separation. When you understand that the atoms in your body were forged in the nuclear furnaces of ancient stars, that the calcium in your bones and the iron in your blood were created in stellar explosions billions of years ago, you begin to feel your deep kinship with the cosmos itself. You're not separate from the universe looking out at it. You are the universe looking at itself, matter and energy that has somehow learned to contemplate its own existence. This perspective can dissolve the artificial boundaries we often create between ourselves and the world around us. The same physical laws that govern distant galaxies govern the cells in your body. The same quantum fields that fill empty space also fill the spaces between your atoms. What else, Preston? I feel empty space also fill the spaces between your atoms. What else, Preston? Indibro gears. The same cosmic expansion that carries galaxies away from each other also carries you through space and time from moment to moment. You are intimately, inescapably connected to everything that exists. Contemplating cosmic boundaries also changes how we think about time and urgency. When you realize that the light reaching your eyes tonight left some distant stars when the pyramids were being built, when you understand that the cosmic microwave background carries information from when the universe was only 380,000 years old, you begin to appreciate both the patience of cosmic processes and the fleeting nature of individual moments. This can bring a profound peace to daily life. The universe has been unfolding its story for billions of years with infinite patience. And it will continue to do so long after we're gone. This doesn't make our brief participation in the cosmic story meaningless. It makes it precious. We are temporary arrangements of matter and energy that have achieved the extraordinary ability to understand and appreciate the universe that created us. Perhaps most importantly, grappling with these ultimate questions cultivates humility. Every time we think we've found the edge of knowledge, we discover new mysteries beyond. Every answer reveals deeper questions. This isn't frustrating, it's liberating. It means that no matter how old you get, no matter how much you learn, the universe will always have new wonders to share with you, new invitations to amazement. The question of what lies beyond the edge of the universe ultimately changes us by connecting us to something larger than our immediate concerns, while simultaneously making us appreciate the irreplaceable nature of our particular moment of cosmic consciousness. We become both smaller and larger, both more humble and more significant, both more aware of our limitations and more grateful for our capacity to wonder about the infinite mystery that surrounds us. As you drift towards sleep tonight, you carry within yourself not just the atoms of ancient stars, but the consciousness that allows the universe to know itself, to question its own boundaries, and to find meaning in the very act of wondering what lies beyond the edges of everything we can know. Picture a child discovering the ocean for the first time, not the gentle, contained experience of a swimming pool, but the vast horizon-stretching reality of the sea itself. There's that moment of stunned recognition, when the child realizes that the water extends far beyond what can be seen, that somewhere beyond the curve of Earth, this same ocean touches distant shores they will never visit. The child doesn't become discouraged by the ocean's vastness. Instead, they become enchanted by the possibility it represents, the promise that there is always more to discover, more to explore, more to wonder about. This is perhaps the most beautiful way to live with the knowledge we've explored together tonight, not as a burden of incomprehensible vastness, but as an invitation to perpetual wonder. The cosmos, whether bounded or infinite, whether singular or multiple, whether comprehensible or ultimately mysterious, offers us something precious, the guarantee that amazement will never be exhausted. In our daily lives, it's easy to fall into the illusion that we understand our surroundings, that we've mapped the territory of our existence and know what to expect. We drive familiar routes, inhabit familiar spaces, interact with familiar people, and the mystery of existence can fade into the background of routine and repetition. But when we remember that we're floating on a small planet around an ordinary star in one galaxy among hundreds of billions, all of it embedded in an expanding cosmos that might itself be just one bubble in an infinite multiverse, suddenly everything becomes extraordinary again. The coffee cup in your hands tomorrow morning contains atoms that were forged in stellar explosions, arranged in patterns complex enough to hold warmth and flavor. The light streaming through your window carries information from a nuclear furnace 93 million miles away, information that traveled through space for 8 minutes to reach your eyes at exactly this moment. The air you breathe connects you to every living thing on Earth through the vast recycling system of the atmosphere. Nothing is ordinary when you remember its cosmic context. Living with wonder in an unbounded cosmos means cultivating what we might call cosmic perspective, the ability to hold both the intimate and the infinite in awareness simultaneously. It means appreciating the extraordinary fact that conscious observers like us exist at all in a universe that could easily have been sterile and empty. It means marveling at the improbable chain of cosmic events that led from the Big Bang to galaxies, to stars, to planets, to chemistry, to biology, to consciousness, to this very moment of contemplation. This perspective doesn't diminish human concerns, but places them in a context that can be both humbling and empowering. Yes, our problems are temporary and small compared to cosmic scales, but they're also part of the magnificent complexity that the universe has achieved through billions of years of patient evolution. Our capacity to love, to create, to suffer, to joy, to wonder, these are not insignificant accidents, but remarkable emergent properties of cosmic evolution itself. Wonder also thrives on the recognition that mystery is not a problem to be solved, but a condition to be celebrated. Each scientific discovery, rather than reducing the universe's mystery, reveals new layers of complexity and beauty. The more we learn about quantum mechanics, the stranger reality becomes. The more we understand about cosmic evolution, the more remarkable our existence appears. Knowledge doesn't eliminate wonder, it deepens it. Perhaps most importantly, living with wonder means staying open to surprise. The universe has repeatedly demonstrated its capacity to exceed our imaginations. Who could have predicted dark energy, quantum entanglement, the cosmic microwave background, the accelerating expansion of space itself? The cosmos seems to delight in being more creative, more surprising, more beautiful than our theories suggest. This means that no matter how much we think we understand, the universe likely has revelations waiting that will transform our understanding once again. As you prepare for sleep tonight, surrounded by the gentle darkness of your earthly home, remember that you're also surrounded by infinite space, filled with wonders beyond imagination. Somewhere in the darkness, new stars are being born in stellar nurseries, their light beginning journeys that might take millions of years to reach other worlds. Somewhere, galaxies are colliding and merging, creating new cosmic structures on scales that dwarf anything in human experience. Somewhere, perhaps, other conscious beings are looking up at their own night sky and wondering about the same cosmic mysteries that have guided our journey together. The question of what lies beyond the edge of the universe remains beautifully unanswered, and in that unanswered state, it continues to invite us into wonder, into humility, into the profound joy of being conscious participants in the grandest mystery of all, the mystery of existence itself. And so our gentle journey to the very edges of everything draws to a peaceful close. We've drifted together through cosmic horizons and quantum possibilities, through the geometry of space-time and the mysteries of dark energy, always returning to that profound question that may have no answer: what lies beyond the boundary of all that exists? And so our gentle journey to the very edges of everything draws to a peaceful close. Perhaps tonight has shifted something in how you see the darkness outside your window, no longer empty space, but an ocean of possibilities stretching toward horizons we may never reach. The universe has revealed itself to be far stranger and more wonderful than we could have imagined when we began. I'm curious, are you still awake? If so, you have my admiration and perhaps my sympathy, for I seem to have failed once again in my mission to guide you gently into sleep, though perhaps staying awake to contemplate infinity is its own kind of rest for the soul. Let me ask you this: knowing what you now know about cosmic boundaries and infinite possibilities, do you feel smaller or larger than when we started? Please, if these midnight wanderings through the cosmos have brought you any measure of peace or wonder, consider leaving a like or subscribing to help these reflections reach other restless souls seeking comfort in the vast mystery that surrounds us all. May you dream tonight of cosmic shores where new universes are born, and wake tomorrow with eyes that see the extraordinary in the everyday, remembering always that you are made of star stuff, contemplating the very stars from which you came. Sleep well, fellow traveler in the infinite.